This is the video for Lesson 4.2, Finding the Greatest Common Factor. Now, a common factor of a set of numbers is a whole number that's a factor of two or more non-zero numbers. The greatest, the biggest of the common factors is the greatest common factor. So next to greatest, you might just want to put biggest so you know what greatest means. So for example 1, we're going to find the greatest common factor of 24, 60, and 36. And there's actually two methods of doing this. The first method is to list the factors of every number and then figure out what the biggest one in common is. Now this is fine, however, if our numbers that we're dealing with are kind of bigger, it's possible that we might leave out a factor and that could affect what common factor we get as an answer. So the method I prefer is method 2. However, let's go through and see how this one works. Okay, for 24, we have 1 and 24. Remember, we list them in pairs to help us out. We have 2 and 12. Next is 3 and 8. We have 4 and 6. And then 5 would be next, but that's not a factor. And then 6, and that's already listed. So we have all our factors of 24. For 60, we have 1 and 60. We have 2 and 30. We have 3 and 20. We have 4 and 15. We have 5 and 12. And we have 6 and 10. And then for 36, we have 1 and 36. We have 2 and 18. We have 3 and 12. We have 4 and 9. And then the last one would be 6 times 6, so we just write 6 once. So if we just wanted to find common factors, we would go through and see which numbers appear on all three lists. So some common factors would be 1, 2, 3, and 4. We have a 6 in each list. And we have a 12 in each list. Okay, the 12 is the biggest of the ones that they have in common. So our GCF of 24, 60, and 36 is 12. Now the other method is to write the prime factorization of each number. And then the GCF is going to be the product of the common factors. Now if you need to make a factor tree while doing this, it's okay, but I think a lot of us can do this in our heads, so we're going to try and do that here. For 24, it equals 2 times 12. And I know 2 is a prime factor, so I'm going to write that down. So that means I really need to figure out what 12 equals. So 12 is 2 times 6, so I'm going to write down the 2. And then 6 is 2 times 3. And so we've prime factored 24, and we didn't even need a factor tree. For 60, it's 2 times 30. 30 is 2 times 15. And 15 is 3 times 5. And then 36, we'll see, is 2 times 18. 18 is 2 times 9. And 9 is 3 times 3. So now you want to find what prime factors are common to 24, 60, and 36. I like to circle them because you can only use it once. So here we have a set of 2's. We have another set of 2's. And then it's going to be a little crooked, but that's okay. We have a set of 3's. Now it says it's the product of the common factors. So I'm going to take each set, and I'm just going to write it once. So I have 2 from this set. I'm going to write down another 2, and I'm going to write a 3. You only write it once, and then you're going to multiply them together. 2 times 2 is 4. 4 times 3 is 12. Okay? So either method works. However, I think method 2 is probably the way we should be trying to go. Right now I'd like you to try numbers 1 and 2 on your paper, so pause the video, and when you're ready, hit play again and see how you did. Okay, I'm going to use method 2, which is prime factoring. So for 12, Okay, 12 equals 2 times 6, and 6 is 2 times 3. For 30, it's 2 times 15. Oops. And 15 is 3 times 5. Okay, so each is prime factored, so now we have to find any common factors. Since there's only two numbers here, it only has to be in the two cases. So I have a common factor of 2. I also have a common factor of 3. And then we have to remember, okay, we take a 2 from this set, a 3 from this set, I'm going to multiply them together, and my GCF is 6. For here, we have 27, 45, and 90. 27 is 3 times 9, and 9 is 3 times 3. 45 is 3 times 15. 15 is 3 times 5. 90 is 2 times 45. Let's see, 45 is 3 times 15, and 15 is 3 times 5. Okay, if you try doing this one in your head, you do it in a different order, that's fine, but when you rewrite it, I would put them in numerical order to help you a little bit more when finding your GCF. So here we have a set of 3s and a set of 3s. Okay, notice here I have a 5 and a 5. However, it's not in all three numbers, so I cannot take this as a common factor. So the only thing I have here is a 3 and another 3. And 3 times 3 means our GCF is 9. Okay, let's flip our paper over. Now we have a new definition. Two or more numbers are relatively prime if their greatest common factor is 1. So for example 2, we're going to see if these numbers we have here are relatively prime or not. So the first step is going to be to find the greatest common factor, the GCF of the numbers. Then tell whether the numbers are relatively prime. So for 24, okay, that's 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. Okay, 45 is 3 times 15, and 15 is 3 times 5. You see, we have a common factor of 3, so our GCF here equals 3. So this would be no, not, I'm going to abbreviate here, not relatively prime. For 35, for letter B, 35 is 5 times 7. Okay, and right away I can tell for 54, okay, in order for them to have a GCF other than 1, 5 or 7 would have to go into 54. Okay, but neither of those two numbers goes into 54. So that means that the biggest thing they're going to have in common is 1. So 35 and 54 are relatively prime. Okay, the final thing is finding the GCF of monomials. Okay, and actually, I don't know why they are not on my paper, on my screen, but these are exponents. So 18xy squared and 28x squared y squared, they're okay over here. Okay, so the first thing is to factor the monomials, just like we did in the last lesson. So 18 is 2 times 9, 9 is 3 times 3, and then we're going to split up all our variables, sorry. So we have 1x and y squared is 2y's. 28 is 2 times 14. 14 is 2 times 7. Then we have 2 x's and 2 y's. Okay, so now we have to figure out what's in common. We have a pair of 2's. That's it in terms of our numbers. We have an x in common. We have y. We have a y. So our final answer is going to be 2. We have 1x. And we have 2 y's, so that would be y squared. So once again, pause the video, try numbers 3 and 4, and then hit play to see how you did. Okay, for number 3, 20x squared would be, let's see, 20 is 2 times 10, 10 is 2 times 5, and then we have 2 x's. 36x, 36 would be 2 times 18. 18 is 2 times 9. 9 is 3 times 3. And I just have 1 x. Circle the common factors. I have a 2. I got another 2. And I have an x. So if you multiply all those circled things together, remember 1 from each category, we would have 4x. Finally, number 4, 32y squared. I know for a fact that 32 is 2 to the 5th power. That's just one of those things that you might start to realize. So times y times y. And 6x squared y would be 2 times 3 times x times x times y. Common factors, we got a 2, and we have a y. And that's it. So our answer for number 4 is 2y. If you have any questions, please make sure you jot them down on your paper, and we'll discuss them tomorrow in class.